3 times 5, which is 15, equals 2t minus 12 by 14, which is 168, right? And then you can move minus 48t to the other side of the equation, which gives you 50t equals, okay, move minus 168 to the left-hand side of the equation, which gives you 183. So now we have the final solution, which is t equaling 83 over 50, right? Okay, you can leave it there, or you can, if you like, you can write it in a decimal format, which is 3.66. So both of them are okay. Okay. Any questions? So the key point here is to find the least common multiple to eliminate all the fractions on both sides. All right, let's see question 2. Okay, again, if you don't like fractions, consider the least common multiple. Okay, again, 6 and 4, the least common multiple, LCM. Least common multiple is 12, right? So we time a 12 on both sides of the equation. Don't forget, you should time the same number on the right-hand side, okay? And next step, by using the distributive law, assign 12 to both of the terms in the brackets, which you will get 2 times 11 minus 4y plus 3 times 2y plus 5, right? And you have a 36 on the other hand of the equation. Okay, and then we can expand all the terms, which gives you 22 minus 8y plus 6y plus 15, right? Equals 36. And now we can merge all the y's. Okay, we can put all the y terms onto the right-hand side of the equation, which gives you 2y. And put 36 on the left-hand side of the equation, which gives you 22 plus 15 minus 36, which is 1, right? So the final solution is y is 1 over 2. Okay, any questions? Okay, no? All right, let's see question 3. Okay, question 3, you can either time both of the equation with a 6, right? Because the least common multiple of 2 and 6 is 6, right? So we can time 6 on both sides of the equation. And next, you should use the distributive laws to assign 6 into the 2 terms in the brackets, right? So the first term gives you 3 times x minus 1. Second term, you have, okay, pay attention to the sign here. You have 3 minus 2x in the brackets, in the pair of brackets. Okay, And next step, we can expand all the terms and remove all the brackets, which gives you 3x minus 3 minus 3 plus 2x, right? Pay attention to the sign here, because here you have a minus sign. And when you remove the brackets, everything inside it has the opposite sign. Okay, then equals minus 36. Okay, and then we can merge all the x's, which gives us 5x, and put all the constants on the other side of the equation, which is minus 36 plus 6, which is minus 30, right? So finally, we have x is minus 30 over 5, which is minus 6. Okay, any questions? Okay, if you have no questions, let's have a look at the next one. Next one, you can try to expand the equation once, because we have a 1 over 2 here. 1 over 2 multiplied by 1 over 2, you will get 1 over 4, right? So I think it's better to expand it a little bit, okay? So for the next step, you have 2x minus 1 over 2x plus 1 over 4 x minus 1 equals 2 over 3 x minus 1, right? Pay attention, again, pay attention to the sign here, because you have a negative sign in front of the brackets. So everything inside brackets, when you move the brackets, everything inside it becomes opposite. Okay, so next, you can consider removing all the brackets. Note that the least common multiple of, we have a 2, right? And we also have a 4. And on the right-hand side, we have a 3. So the least common multiple of 3, 4, 2 is how many? 12, right? So again, we time a 12 on both sides of the equation. And next, we use the distributive laws to assign the 12 inside the brackets, which gives you 24x minus 6x plus 3 times x minus 1 equals 8x minus 1, right? Okay, next, we can expand the equation. 24x minus 6x plus 3x minus 3 equals 8x minus 8, right? And then try to merge all the x's, which you get 13x on the left-hand side of the equation. And also, we need to move minus 3 on the other hand, which gives you a minus 5, right? So the final solution is x equals minus 5 over 13. Okay? Any questions? So as you can see here, for the simple equations like this, there's nothing special. All you need to do is to be careful and step by step, slowly. Okay. All right. Let's see question 5. Question 5. If you want to solve, okay, note that we need to solve for x, right? If you want to solve for x, you need to merge all the terms that contains x together, right? So first of all, we need to expand all the terms, which gives you square root 2 times x minus square root 2 equals x plus 1, right? And next step, as I said, you need to merge all the x's, which gives you square root 2 minus, okay, I'll write one more step for you. Square root x minus x, and move all the constants to the other side of the equation, which gives you 1 plus square root 2, right? So next time, because x is a common factor, so we can put it in front of square root 2 minus 1 equals 1 plus square root 2, right? So here you can see how to solve x. Of course, we can divide both sides of the equation with square root 2 minus 1, right? So this is our final solution. But usually we need to simplify it, right? So in order to simplify it, all you need to do is to times square root 2 minus 1 or plus 1 on both of the denominators and numerator. Okay, because a square, because we have a formula, a plus b times a minus b is a square minus b square, right? So in the denominator, we have square root 2 minus square root 2 square minus 1 square, which gives us a 1, right? So for the numerator, we're going to use this formula, which is a plus b square is a square plus 2ab plus b square, right? So here we have square root 2 plus 2 times square root 2 plus 1 square, right? So the final result is 3 plus 2 times square root 2, okay? Have a look at these. You have any questions? So the takeaway here is when you want to solve for some unknown x, the important thing is to move and merge all the terms that contains x together, right? Okay, so next time when you encounter a problem like this is the method to solve it. Okay, if you have no questions, let's move forward. Section 2 is about some more complex equations related to one variable linear equation. But in essence, they are actually equivalent to one variable linear equations. Okay, let's have a look at them. Question 6. Okay, again, we have square root 5x on the left-hand side and the square root 5x on the other side, right? So you can consider merge them. So the method 1, you can merge them directly. Okay, just put the minus square root 5x to the right side of the equation and move all the constants to the other side, which gives you 6 plus 8 equals square root 5x plus square root 5x. So here you have 14 equals, you have 2 square root 5x, right? So 2 times square root 5x. So that means square root 5x is actually 7, right? When you have something's square root is 7, that means the number inside the square root is actually 7 to the second power, or 7 to the second order, right? So that means 5x is 49. This gives you x is actually 49 over 5, right? Okay, this is method 1. Okay, if you are not very familiar with this, we also have a method 2, right? If you don't like the complex expression here, you can consider substitute the square root with a letter u. So let's use the letter u to substitute square root 5x, right? Then the original equation actually becomes 6 minus u equals u minus 8, right? So now, as long as we can solve u, we can solve x, right? Because there is a connection between u and x. So in order to solve u, we put u on the right-hand side of the equation. This gives us 2u, and put out constants on the left-hand side of the equation, which gives you 14. So that means u is actually 7, right? So when you have the value of u, that means the square root of 5x is actually 7, right? Because u is actually square root 5x. So this gives you 5x is 7 to the second order, which is 49. And then you can also solve x is actually 49 over 5, right? So both of these two methods will do. Okay, you can choose either method you like. Okay, any questions? No? All right. Question 7 is very similar to the previous question, right? Because you have some expression like square root something, for example, square root of a triangle on the left-hand side of the equation. And you have the same similar expression on the other side of the equation, right? So you can try to merge them. So method 1, merge them directly. We put the minus square root to the right side of the equation. This gives you, at the same time, we put the constant on the left-hand side. This gives you 9 minus 5 is square root 3x over 5 plus another square root 3x over 5, right? And then you can merge the two terms on the right-hand side of the equation. This gives you twice of square root 3x over 5, right? Okay, so this actually means square root 3x over 5 is 2, right? So when you have something's square root is 2, this means the number under the square root sign is actually 2 to the second, which is a 4, right? So this gives you 3x is actually 20. That means x is 20 over 3, right? Okay, and of course, if you cannot see it directly, there is also a method too, okay? For an equation like this, this is not too complex. You can just use the method 1 directly, okay? But if you have encountered a more complex equation, and the equation has a very similar form compared to this, you can consider using method 2 to make it simpler, right? So we can use a letter U to denote the complex expression here. Let U be square root 3x over 5. So the original equation becomes 9 minus U equals U plus 5, right? And this equation looks simpler. And if we can solve U, we can then solve X because there is a connection between U and your X, right? So here 2U equals 14. That means U is 7, right? And because U is square root 3x over 5, that means your 3x over 5 square root is actually 7, right? So this means 3x over 5 is 7 to the second, which gives you a 49. Sorry, it's not 14, it's a 4 here. My bad. U is not 7, U is actually 2. And 3x over 5 is 2 to the second, which is a 4. So that means 3x is 20, and x is 20 over 3. Right? Okay, have a look at these. Do you have any questions? No? All right, let's see question 8. Question 8 also is very similar to the last one because you have very similar terms on both sides of the equation, right? So also we have two methods. Method 1 is to merge these two terms directly. So all you have to do is to move this term on the right-hand side to the left-hand side and move all the constants to the right side of the equation. So this gives you 3 times the complex expression minus the complex expression here equals 17 minus 11, right? So now 3 times this minus 1 times this. According to the distributive law, you can put the common factor in front. And what's left in the brackets is 3 minus 1, right? And on the other side of the equation, you have actually 16. So that means cube root of 4 minus 2x is actually 8. Sorry, it's not 16, it's a 6. 17 minus 11 is 6. So 6 divided by 2 is 3, right? So when you have a cube root of something is 3, that means the value of the expression inside the cube root is actually 3 to the third, right? Which is 27. So this means 2x is 4 minus 27, which gives you minus 23, right? So x is minus 23 over 2, correct? Okay, and always we have a method too, if you cannot see it directly. If you don't like the long expression here, consider using another letter to denote the complex expression. Here we let you denote cube root of 4 minus 2x. It's workable, right? So then the original equation becomes 11 plus what? 3u, right? Minus 17 equals what? Equals u, right? Because now we use the letter u to substitute this long expression here. And then for this equation, it's very easy to solve, right? And if we can solve u, then we can solve x because there is a connection between u and x, right? So for this specific equation, we have 2u equals 17 minus 11, which is 6. Okay, 2u equals 6 means u is 3, right? Because u is cube root of 4 minus 2x. That means cube root of 4 minus 2x is 3. Okay, this means the value under the cube root is actually 3 raised to the third, which is 27. Okay, this means 2x is minus 23. This gives you x is actually minus 23 over 2. Correct? Okay, have a look at it. And if you have any questions, please let me know. Okay. Okay. No questions? Okay, let's move forward. Question 9. Okay, this method is the same. On the left-hand side, you have a very long expression here, right? But on the other side of the equation, you have the same expression. So consider this as your u, right? So we can combine all the u's on the left-hand side. This gives you actually 3 times fifth root of x minus 5, right? Equals, okay, and now we put all the constants on the other side of the equation. This gives you minus 18 plus 13, which is actually minus how many? 6, right? Okay, and now we divide both sides of the equation with a 3. This gives you fifth root of x minus 5 is minus 2, right? Okay, next step is when you have fifth root of something is minus 2, that means the value under the fifth root is actually minus 2 raised to the fifth power, right? Okay, which is minus 32, because minus 2 to the fifth order is minus 32. Okay, so this means x is minus 32 plus 5. Which is minus 27, right? Okay, so this is all method 1. Again, we have method 2, which is to let a letter U to denote a very long expression, which is x minus 5, and there's a fourth root. Okay, this gives you 19 plus 4u minus 13 equals u, right? And this is very easy to solve for u. This gives you 3u is minus 6. That means u is actually minus 2. Okay, because there is a connection between u and x. All right, this is a 5, not 4. That means fifth root of x minus 4 is minus 2, right? So that means x minus 5 is actually minus 2 raised to the fifth order, which is minus 32. So the final solution is, again, x is minus 32 plus 5, which is minus 27, right? Any questions? No questions? Okay, let's see question 10. All right, question 10, there's nothing special. If you want to solve for r, just try to merge r to the twice and the linear r respectively. Okay, first let's merge as much as we can. So here we have 5r to the twice plus r minus 3r plus 2r is 25, right? We can put the constants on the other side of the equation. So here plus r plus 2r minus 3r is actually a 0, right? So this means we have 5r to the twice equals 25. This means r squared is 5, right? Okay, now this is a key step. You know that something squared is 5. Then how much is this thing? It should be plus or minus, right? Square root 5. Do not forget the minus square root 5, all right? Okay. Okay, all right, let's consider another similar problem. If I tell you that r to the fourth order is, for example, 16, how much is r? R could be a 2, right? But do not forget that r could also be minus 2. So what's the takeaways here? What's the takeaways here? When you have something to an even number of order equals something. So usually how many solutions do you have here for R? You have 2 solutions, okay? Of course, this thing should be above 0, right? Cannot be less than 0. If it is less than 0, there is no solution. Do you understand? Okay, I'll rewrite this for you. Okay, let's make a summary here. If you have something, for example, x to an even order equals another number, for example, y, and y is above 0. how many solutions are there? There are 2 solutions, right? And if you have x to the even power equals to a y and y is 0, how many solutions are there? There is only one solution, right? The only solution is 0. Okay, when you have something raised to the evens order equals to y and y is less than 0, how many solutions are there? You have 0 solutions, right? Because some number raised to an evens order, you cannot have a negative number, right? Are we clear about this? Okay. So next time, do not forget the other solution, okay? Okay, all right, have a look at this. If you still made a mistake on this question, please update your error book, okay? Put this typical question onto your error book. Okay, no questions? All right, let's see question 11. Question 11, you want to solve for y, right? Okay, remember here we want to solve for y. So intuitively, when you want to solve for y, you should put all the terms that contains y together, right? And put all the constants to the other side of the equation. But there is nothing we can do here, right? Because you cannot merge them directly. So first of all, I think it's better to rewrite the left-hand side into a single fraction, right? So the first step, we can rewrite it into a single fraction. This gives you 3 plus square root 2y times 3 minus square root 3y. And this is a least common denominator, right? So the first terms, okay, I'll write one more step for you, okay? Let's rewrite this. Okay, this is the least common denominator. Okay, when you transform the first term to this one, you should times the same number on the numerator, right? This is your first term. How about the second one? Second one, you changed the denominator to this one, right? You transformed the denominator to this one. So in order to keep the value unchanged, you should times the same number onto the numerator, right? And equals 5. We did not do anything to the right-hand side of the equation. We simply rewrite the left-hand side using the least common denominator. So here you have 3 minus 2 square root 2y plus 3 plus 2 times square root 2y. And now you can see that these two terms can be cancelled because minus 2 of it plus 2 of it is 0, right? So here equals 5. Okay, so this means 6 over 3 times. Okay, I'm going to rewrite this. Note that you can use this formula here. A plus b times a minus b is a squared minus b squared, right? You can use this formula to rewrite the denominator here. So the denominator becomes 9 minus how many? Oh, sorry, I made a mistake. There's no 2. Okay, now it's correct, right? Okay, so the denominator becomes 9 minus 2y, right? And equals 5 on the other side. Okay, so by using the cross multiplication method, the equation can be rewritten as 5 times 9 minus 2y equals 6. Correct? Then we have 45 minus 10y equals 6. Okay, that means 10y is 45 minus 6, which is 39, right? So the final solution is y equals 3.9. Correct? Any questions? No? All right, let's see question 12. Okay, question 12. Question 12, note that we have t minus 3 and also 3 minus t, right? T minus 3 is actually minus 3 minus t in the brackets. So first of all, we can try to rewrite the second term, which is plus 6 over minus t minus 3, right? And this equals 10. And then we can put the minus sign in front, which gives you 2 minus t minus 3 minus 6 over t minus 3 is 10, right? So these two terms are using the same denominator, so we can combine them. So this gives you 2 minus 6 over t minus 3 equals 10, right? Okay, next, you can use cross multiplication to rewrite this equation in a multiplication form, which gives you 10 times t minus 3 is minus 4, which means 10t minus 30 equals minus 4, right? Okay, then we have 10t equals 30 minus 4, which gives you 26, and t is 26 over 10 is 2.6, correct? Okay, next one. All right, next one, note that we can use a cross multiplication method for the first step and move these to the right-hand side of the equation, right? If we do that, we can try to cancel something. So first of all, let's use a cross multiplication method. This gives you 5 times square root 3x plus 1 plus square root 3x minus 1 equals 7 times this, right? This gives you 7 times square root 3x plus 1 minus 7 times square root 3x minus 1, right? And then we can merge these two and these two, right? So this gives you, okay, we can put this in the left-hand side and put this term on the left-hand side. This gives you 8 times square root 3x minus 1 equals 2 times square root 3x plus 1, right? And we can divide both sides of the equation with 2. This gives you 4 times square root 3x minus 1 equals to square root 3x plus 1, right? Okay, next, we can divide both sides of the equation using 3x minus 1. Okay, next, this actually gives you square root of 3x plus 1 over 3x minus 1 is a 4, right? So when you have a square root of something is 4, that means the value inside the square root sign is 16, right? Okay, so this gives you by multiplication, cross multiplication, this gives you 3x plus 1 is 48x minus 16, right? Okay, and then we put all the x's together. This gives you 45x equals 17, right? So here we have x equals 17 over 45. Okay, any questions? No? Both okay, right? Okay, let's see question 14. I can see that you don't know how to solve it, right? Okay, by first glance, there's no better way we can do this. So consider if we can merge something here, okay? Note that you can put x inside the square root sign, and also you can put 2 inside the square root sign, right? And actually, square root 18x is 3 times square root 2x, right? Okay. And if you put x inside the square root sign, you also can have square root 2x here, right? For the second term, If you put 2 inside the square root sign, also you will have a square root 2x. So now you have square root 2x for the first 3 terms, and then you can merge these terms actually, right? So let's try using this method. So if you put x inside the root square sign, how much do you get there? You will have actually this, right? And for the second term, you will have x over 2 times a 4, correct? And for the third term, we already know that it can be rewritten as 3 times square root 2x. Is that correct? Okay. Right hand side does not change. It's a 10. And next step, x can be cancelled with x. This gives you square root 2x. Next, 2 cancels with 4, gives you 2x again. Okay, next, 3 times square root 2x equals 10, right? Now can you see how to solve it? 1 times square root 2x, 1 times square root 2x, 3 times square root 2x. So the common factor is square root 2x, right? So according to the distributive law, we can put it in front. And what's left in the brackets? It's a 1 plus 1 plus 3, right? Equals a 10. Okay, so this means square root 2x is 10 over 5, which is a 2, right? Okay, when you have a square root something is 2, that means value inside the square root sign is actually a 4, correct? So the final result is x is 2, but it's not over yet because the x is under a square root sign, right? So when you have the final result, it's always safer to put it in the original equation to check if this sign is really the solution. Okay, because if you have an x less than 0, for example, if you have a solution that x is less than 0, that could happen because in the first step, when you put x inside the square root, it's actually does not constrain that x must be above 0, right? So when you have a solution which is less than 0, it is not the real solution of the original equation. So for an equation like this, it is always safer to put the final result inside the original equation to check if it does satisfy the original equation. Understand? Okay. Another explanation is that actually the square root of x squared is not equal to x. It's actually equals to x absolute value of x, right? For example, if x is a 2, if x is a minus 2, for example, when x is minus 2, the square root of x squared gives you a square root of 4, which is a 2, right? This is not equal to x. It's actually equals to the absolute value of x, which is a 2. Can you see that? Do you see what I mean here? Okay, doesn't matter if you don't quite understand what I'm talking about. I probably will talk about this in the future. Okay, let me have some problems involving this expression. We'll talk about that later. Okay, any questions? No? All right, let's see the next one. Question 15 is actually the same with question 6. I'm sorry, no 6. It's the same with question question 5. I'm sorry, I write this question twice. So let's see question 5. These two questions are actually the same. I forgot to delete one of them. Okay, and so let's see question 16. Okay, question 16. Okay, first of all, we can cancel a minus sign, right? Because we have both -1 on each side of the equation. So first of all, you can divide both sides of the equation with -1. This gives you twice of square root 2x equals square root 12. Square root 12 is actually twice of square root 3, right? So next we can cancel a 2 on both sides of the equation. So this gives you square root 2x is square root 3. Okay, so this means 2x is 3, right? And x is 3 over 2. All right, any questions? No? Okay, let's see the next one. Next one, actually, there are two methods. Okay, method 1, we can use a formula that a plus b to the second order is a squared plus 2ab plus b squared to expand the first term, right? And using a plus b times a minus b equals a squared minus b squared to expand the second term, right? So following this logic, the left-hand side becomes x squared plus 2ab is x plus b squared, which is 1 over 4, right? This is your first term. Next, you have a plus b times a minus b. This gives you x squared minus 1 over 4, right? Because 1 over 4 is 1 over 2 to the second power. And this is 1. And then we can expand the left-hand side, which is x squared plus x plus 1 over 4 minus x squared plus 1 over 4, right? Because you have a minus sign here. So just pay attention to this. And next step, of course, we can cancel these x to the second power. This gives you x plus 2, 1 over 4 is 1 over 2, right? So the final result is x is 1 over 2. Dora, I'm sorry, I marked your question 17 wrong. Your solution is correct. Dora, I'm really sorry for that. Okay, my bad. Okay, we can also have method 2. Okay, method 2, actually note that the left-hand side can be rewritten in this part, right? So instead of using the formulas, note that there are some common factors on the left-hand side. This is a common factor of these two terms, right? So according to the distributive law, we can put the common factor in front. And what's left behind is x plus 1 over 2 minus x minus 1 over 2, right? Because when you distribute these terms to the terms inside the brackets, you will have the original equation. Okay, so in this way, this gives you x plus 1 over 2 times x plus 1 over 2 minus x plus 1 over 2 is 1. And this gives you 1, right? So that means x plus 1 over 2 is 1. And then you know that x is 1 minus 1 over 2, which is 1 over 2. Right? You can use either method. Any questions? No? Okay, let's see the next one. Okay, next one. You can consider transforming the decimals to fractions, because usually we don't, it's not very easy to handle both the fractions and decimals, right? Because here you have a fractions on the left-hand side, and at the same time, you also have the fractions. So for me, I can, usually I'll do this, x plus 4 over 0.2. 0.2 is actually 2.10, right? Sorry, 2 over 10. 2 over 10 is actually 1 over 5. So you can rewrite this as 1 over 5. And the next term, x minus 3 over 0.5. 0.5 is easy, which is 1 over 2, right? And this equals to minus 1.6. 1.6 is actually 1 plus 6 over 10, right? 6 over 10 is actually 3 over 5. And 1 plus 3 over 5 is 8 over 5, right? So we can rewrite the right-hand side to minus 8 over 5. So the advantage to rewrite it in odd fraction form is you can see that x plus 4 divided by 1 over 5 is actually multiply the reciprocal of this number, right? Which you will have 5 times x plus 4. Again, similarly, x minus 3 over 1 over 2, this actually is a multiplication. 2 times x minus 3, right? And equals 8 over 5. And now we can try to merge all the x's on the left-hand side, which gives you 5x plus 20 5x plus 20 minus 2x plus 6, right? Equals minus 8 over 5. So this gives you 3x plus 26 equals this. And 3x equals yes, this is 138. And finally, you have x is minus 46 over 5. And also you can rewrite it as a fraction in final, which is minus 9.2. Both of the two numbers are okay. All right, any questions? Also, you can also use another method. I'll write it here, okay? Method 2 is to eliminate all the decimals. You can time something on both sides of the equation, right? So what's the number should we time? Can times, how about the 5? 5, no, it does not work. So how about a 10? Oh, actually 1 over 10, right? Let's try this. You can time 1 over 10 on the left-hand side of the equation. And at the same time 1 over 10 on the right-hand side of the equation. So according to the distributive laws, on the left-hand side, you will get x plus 4 over 2 minus x minus 3 over 5, right? And minus 0.16. Next time, you want to eliminate all the fractions, so you need to times least common multiple, which is a 10, to both sides of the equation. So this gives you 5x plus 4 minus 2 times x minus 3 is minus 1.6. And next you have 5x plus 20 minus 2x plus 6 is minus 1.6. 3x is minus 27.6. And x is actually minus 9.2. Okay, so method 2 will also work. You can choose either way. All right, any questions? Okay, if you have no questions, let's look at question 19. Okay, question 19, you can use actually the similar methods compared to question 18. Okay, for me, I'd prefer to convert them to fractions. So 2.4 is actually 24 over 10, right? 24 over 10 is actually 12 over 5. Okay, so 12 over 5 minus x minus 5 over 0.4 is 4 over 10, which is 2 over 5, right? And equals 1 minus 2x. Okay, 0.05 is actually 5 over 100. 5 over 100 is 1 over 20. So next step, we have 12 over 5 minus x minus 5 divided by 2 over 5 is actually times its reciprocal, which is 5 over 2, right? Next, 1 minus 2x divided by 1 over 20 is actually times its reciprocal, which is 20. Correct? And now we can consider time both sides of the equation using a least common multiple. Least common multiple of 5 and 2 is 10, right? So we time both of the equation is 10. And this gives us 12 times 2 minus 25 times x minus 5 equals 1200 times 1 minus 2x, right? So now all the coefficients are integers. So this is good. And now we can merge all the x's and all the constants. 24 minus 25x plus 125 equals 200 minus 400x, right? Now let's merge all the x's. 400 minus 25, which is 375x, right? And put all the constants on the other side of the equation, which is 1200 minus 24 minus 125. This gives you 51. So here the final solution is x equals 51 over 375. Correct? Okay, have a look at these. Any questions? No, actually this number is not the simplest. You can divide both of the numerators and denominators using a 3, right? This can be simplified to 17 over 125. Okay, any questions? No? Okay, let's see the last question. Actually, should be question 20. Okay, there's nothing special about this equation. First, let's try to expand everything and then try to merge the corresponding terms together, okay? So first step, let's expand everything. First term, you have x to the third plus 3x. Next, you will have 2 times x to the third minus 3x squared, right? Next, you will have, according to the distributive laws, pay attention that there's a minus sign in front. So everything inside the brackets changes to the opposite sign. This gives you 3x to the third plus 3x squared plus 3x equals 12, right? And then next we can try to merge similar terms. So first of all, x to the third. Okay, x to the third, twice of x to the third, minus 3 times x to the third. So these three, sum of these three is actually 0. Next, consider x to the second power. So this gives you minus 3x squared plus 3x squared. Also, these two cancels with each other. The sum is 0. So actually, what's left in the left-hand side is only 6x, right? And 6x equals 12 on this other side of the equation. So the final result is simple, which is x is 2. Correct? Any questions? No? Okay. Have a look at these questions. If you have any questions, please let me know. All right. At the meantime, I'll upload the teacher's notes onto our Google Classroom.